Hi, and welcome to the 2018 Paper 2 of the Junior Cert Higher Level. This is question 6 we're on. If you see in the description below, if you want to set the notes I'm working off, just send an email to shanetroy@gmail.com. And as usual, I say pause the video or just have a go and see if you can get it. If not, just move on and the answers are on the next page, whatever. So question 6 here, and 16 girls, 14 boys. So 16, 14 is 30, okay? You know what, might be worth doing that particular sum. So 16 and the 14 equals the 30. Okay, now I'm just doing that. I've probably secured an attempt by doing that. On a school tour to Barcelona, it doesn't matter. The weight of each student's bag in kilograms is shown in the tables below. So your table here of the 12 girls' bags and the 14, 1, 2, 3, 4, 14 and 16, so 14 boys, 16 girls. Part A then is only worth 5C, so not many marks. The mean weight of the girls' bags was 8.6, so you know the answer, okay? You could work it out yourself if you wanted, by just adding them all together, dividing by 16. Work out the mean weight of the boys' bags, correct to one decimal place. So, in one sense, easy peasy. Okay, the formula here, the mean is equal to the sum of the data, all divided by the number of data points, or just add all your data, divide by the number of them. So, the simplest I'll go to the answer here on the next page. So, I've got the formula again, it's in the maths tables. Add all my data together, so 5.9, 6.8, 7.4, 8.5, and onwards. I'm showing the calculation, so that if I do make an error in the calculation, I'll have wrong answer, but I'll have shown my work, so I probably get the 3, okay, if this was correct. If I have the wrong answer, no work shown, 0. Okay, so make sure you show the sample calculation. Put to the calculator, whatever, I end up with 122.2 over 14, okay, which would have given me the decimal answer using the calculator. Now it's 8.72 and it continues. I want to round that to one decimal place like the question asks. So the 2 is less than 4, so the next number stays the same. So 8.7, and my units were told me as kilograms. Okay, part A. Now part B here gives me a blank empty table. Now before I do anything, it's a grouped frequency table, so instead of having individual answers, you have intervals as such. Okay, now we do that sometimes when there's lots of raw data. So, and the raw data is all very different. You can imagine with this previous data, there's only one person with 5.8. If I was doing a scale here, maybe 5.8, one person, 5.9, 0 people, 6.0, 0 people. You end up with a huge table that doesn't, frequency table doesn't help you, okay? Whereas a group frequency table loses something in that translation to a group frequency table, but it makes it more digestible, okay? So you need to kind of understand the background of statistics in order to be able to answer questions at the honors level. So it's always worth going back and reading the chapter, the beginning of the chapter in the book, just to get some familiarity. Maybe Google, well, Googling is a double-edged sword in the sense that you'll end up with like some very complicated stuff. But as a suggestion for the future, as you are going through sections in Leaving Cert, make sure you do digest the beginnings of books on chapters to give you context about what the section fits in. Okay, but part B here says basically fill in the table. Okay, now we need to use the raw data from before. I'm going to fill in the number of girls' bags first. Okay, and we'll have the answer there. Okay, it's just a matter of going back to your thing. Between 5 and 6 in the girls, there's one person. Okay, between 6 and 7 in the girls, there's 1, 2. Okay, 2 people. Between 7 and 8, there's 1, 2, 3. Would that be counted? Maybe 2. Okay, so 2 people. Yeah. What's happened there is the 8 will be counted in the fourth interval. Okay, so between 8 and 9, okay, there's the 1, 2, 3 people. Between 9 and 10, or 9 and 11 probably. 1, 2, 3, 4, 5, 6, 7. Okay, so we 7 people. Backwards. See, 7 people between 10 and 11. There's none between 11 and 12. That's that last person. There's one person. Now, the same thing with the boys. Okay, you end up with the answers like that. And happy days. No real calculations needed, although there's a bit of space there for it. Okay. And just as long as you're careful, that should be pretty cool. Now, B and C are marked together. Okay, so if you get one part correct, you probably get the 8. Okay, so hopefully you got the 8 so far. Now, I personally dislike these kind of questions. They can be very hard to pin down and say what you actually want to say, even if you do understand it. But Owen says a statement. In general, okay, the girls took heavier bags than the boys did. Okay. Based on the data above, is Owen correct? Why? Give a reason. Okay. You see their answer is no. Okay. So, in my opinion, or that's the opinion of the marking scheme, Owen's not correct. Now, the reason, simply, if you look at it, okay, now remember there's 16 girls, 14 boys. There's one girl with a really heavy bag, okay, one boy with a fairly heavy bag. Now, we don't know if that bag's like 11.1. Now, we actually do know because we have the raw data, but just from the table, could be 11.1. This boy here could be like 10.9, okay, so very similar. There is 2 spare girls, okay, so all along the girls are carrying looks like heavier bags, okay, but there's not much difference all the way along. So it's not outrageously clear that they are, okay. Now, a simple way of looking at it, if you go back to the mean, okay, the mean of the girls was 8.6, the mean of the boys was 8.7. That's an indication that the data of the boys is more skewed or more heavily in the direction of the heavier bags. So the mean doesn't really back it up, the calculation. And even the table itself, there's not a huge difference here. That's enough that you could definitively say, like, that definitely the data. Like, there is information lost. Like, we know there's 13 people with a bag between 9 and 10, but all 7 of those girls could be 9.1, and all 6 of the boys could be 9.9. Okay, we just don't know without looking back at the raw data. So there's a number of ways of saying that. It is tricky. Okay, I've said 2 different options there. As long as it's valid and talking about the data, okay, you should be in a good position. Okay, and if there's not a clear difference, like these kind of questions, if there's a difference, it's designed to be fairly obvious. Those numbers look fairly similar. So even if you said the numbers look really similar, I don't think Owen's correct enough, or it's not clear that he's correct or incorrect. That should be enough. Okay, so that's B and C. Now part D here is worth 10 marks, so getting a good chunk. The table below shows the length of time it took the students to get through security at the airport. You have, again, a grouped frequency table. So we don't know if these 4 students all took 4 minutes or 5 minutes, or all of them took no minutes. Now, no minutes wouldn't make much sense, but whatever. You get the idea. So you got the different number of students. Now it all adds up to give you, what would that be? 12, 23, 29, 30, yeah. Okay. So it's the same students. Okay, sorry, I'm being a bit dumb. It's giving you here an indication just that when you got an interval, okay, does the 10 end here, start here? Okay, can't do both. So they're saying that it's not quite 10 minutes, it's like 9 minutes, 59 seconds. Okay, and then 10 minutes hits. So just in case there's a problem with that. It says part D there says draw a histogram to represent this data. Now, a histogram is only really problematic if there's different sizes of intervals. There's difference of 5 there, 5 there, 5 there, 5 there, 5 there, 5 there. So this is basically a bar chart. Okay. Now we need our such y-axis and x-axis. We need to label them. Okay. And we need to just draw. If we decide here that this is 1, 2, 3, 4, whatever, 5 minutes, and then you have your between 0 and 5. You have your box. That maybe you draw your thing there carefully, okay, and use a ruler, okay, and you'll end up with this your first bar. Now I have the answer done out here. That's our first bar at 4, second bar up to 8, third bar up to 11, and then they're all the same width and they touch, okay. The bar chart could be separated. In a histogram they don't. There's no gap between the bars. The 15-20 is up as far as 6. There was nobody in the 20-25 minutes, so there's no bar. And then 25 and 30, there's 1. Okay, and then those bars there aren't spread out. There just is no data for that particular range. That's it. We have our frequency and our time. So it's labeled. Job done. 10 marks. Okay, now part E here says the table below shows the amount of money that the 30 students spent at the airport. The amount of money they're given again in the group frequency table, so there's ranges. And it gives the number of students who spent whatever. Now, who the hell is that much money has a student go to an airport? But it's fairly spread out. It's small, rises up, and then drops off lower than it started. Okay. It says use mid-interval values to estimate the mean amount of money spent. Give your answer in euros correct to the nearest cent. Okay. So if you think about it here, the mean is usually the middle. Okay. Now before we do the calculation, I can have a ballpark answer. It skews towards the largest side. So it could be a small amount, 3 versus 9. Okay. So the middle, your data is there. Okay. It's going to pull this direction. So I'm going to estimate my answer to be in and around 7-ish. So let's see if we get that from the calculation. Okay. Now our mid-interval value, okay, is the halfway point between 0 and 5. Remember, the trick with understanding a group frequency table is simple. Those 5 people could have spent no money, or they could have spent like almost €5. Okay. We don't know. Without going back literally to the raw data and seeing that one person spent €1, and the next person spent nothing, the next person said 1, the next person, we don't know. So do we take our value as being 0, or do we take it as being 5? Or what happens in most things in life, do we split the difference? Okay. Now, if you split the difference, you're going to end up with adding those two together, 0 and 5, divide by 2, so effectively get the mean of the interval, and that'll be 2.5. Okay. So I'll go to the answer here. If your mid-interval values, I've written them in here just for illustration for you, okay? 15, halfway between 20 and 30 is 25, etc., etc. We're going to use our formula for the mean. Now, this is mean of a frequency table, okay? So it's the sum of the data times the frequency, all divided by the sum of the frequencies, okay? So we take the first one, that's 2.5 times the frequency, plus 7.5 times 4, plus 15 times 7, plus 25 times 8. Now, you see it's all reflected here in the calculation. Again, just for the reasons I said earlier, if I do get the wrong answer, I have the work shown, I'll do pretty well, probably the 7. Okay. I divide by the sum of the frequencies, which is the add up all the number of students. Again, is 30. Okay. Same students we're talking about. Throw to the calculator. I got this decimal. Okay. Goes on forever, whatever. I'm asked to correct that to nearest cent. So that's after 3 decimal places. Okay, I need to look at that number and decide what to do with the cent. So it's 6 is greater than 5. The 1 rounds up to 2. So I end up with €26.42. Job done. Okay, so that's part E. This is a long question. Part F now, worth 5B, so hopefully we're towards the end. Use the values in the table to estimate the median amount of money spent as accurately as you can, and then give a reason for your answer. Okay, now there's still the same 30 students, so they're pointing that out to us for a reason. Okay, so let me go to the answer here. Okay, just let that sit for you for a second, okay? But as you're reading through that, whatever, we want to use the table, and I probably should have screen grabbed the table in there so we have it right in front of us, but I'll go back to it. We need to estimate the median. Now, what is the median? Okay, now it's the middle value when things are arranged in increasing size. Okay. So when we're looking at statistics, we're looking at 2 concepts. One is the average, which represents the mean, median, and mode. And the other thing we're often looking at is the spread of data, like the range or whatever, the interquartile range, or in the future, like standard deviation. So the mean, we've done that twice already. The mode, we haven't been asked, okay, yet, whatever. So the mean is the other one they often ask. And it just gives us an indication of like what's the most common value, okay? Now, if we look back, or not the most common, this mode, what's the middle value? So if I go back to my table here, okay, now, actually I have to go back to this table here because it's blank, and it should be the middle value. Now we said earlier, there's not too many values this side, there's a whole pile of values this side. So we said the mean would be dragged that direction, okay. Now, same thing with the median, okay, so there's 9 this way, now 2 and 6, 6 is there, take a few from that would be like, maybe if I cut this as a part of it, that whole thing there represents 9. Okay, so you got this, then that's the middle bit there. So we said that's probably about 5 left over from that, and 7 there. Now, where would the middle point lie between 7 and 5? It's probably somewhere along here. Okay. Now, we don't know if, again, everybody here, all 7 students spent a tenner, spent 20, or different amounts in between. But if we were to assume that the 7 spent a spread across it, so 1 or 2 spent 11, 12, another 1 or 2 spent 14, 15, and another 1 or 2 spent 18, and maybe somebody spent 19. That middle, which is like kind of represented by cutting that rectangle off a little bit, would be kind of 4/5 of the way across that, which would be around 17, 18, 19 euro. Okay, call it 17, 18, whatever, and you end up with this answer. Okay, the mean is the middle value. In an even list of numbers, there are 2 middle values, 15 and 16. Either way, the 2 middle values would be within the 10 to 20 group. Okay, now we estimated by just looking at the values and giving a kind of iffy thing. This is a bit more precise in the sense that the 15 to 16 would be the median. Okay, 15 to 16 person, 5 and 4 is 9. Okay, 9 and 7 is 15, 16 is again just in that chunk there. Okay, which would be around the 4/5 of between 10 and 20, which would be about 18. So again, the last point there, they're probably at the end of that group, so we'd estimate around 18. But if you said just left it 10 to 20, you should be doing fairly well because, again, you don't know if all 7 spent only a tenner. They are asking to estimate though, so 10 to 20 is not an estimate. It's I'd have to look at the market scheme again, but look, I called it there for a reason. Okay, at 18, so I'm assuming that was what the market scheme said. Anyway, that's F, so I think that should be it. Yeah, that's the end of question 6. So thanks for your time. It's a bit long at 17 minutes in, okay, but it's a long question worth a pile of marks. So best luck and see you on question 7.